Okay, so now we're combining functions again, but this time we're dividing them. So this means do function f divided by function g. So in this case, function f is 2x plus 5. We're dividing it by function g, which is x plus 5. So there's your f over g of x. And they want to know if there are any domain restrictions. The domain restrictions come from the denominator. Anytime you're dividing by something, that something is not allowed to be 0. And so we're looking at this and saying, you, x plus 5, you better not go to 0. If you do, we get something divided by 0, and if you ever divide by 0, the universe explodes. You can't do that at all, and we're not going to show you how next year either. We seriously can't. So x plus 5 is never allowed to be 0. You can solve that. Just pretend it's an equals sign, take the 5 over to the right, and you get x is never allowed to be negative 5. That would be your domain restriction. The domain for this thing would be x can be any real number except negative 5. Now they give us something more complicated. X squared minus 2x minus 35 over x minus 7. Again, the non-permissible value is when we're saying x minus 7 is not allowed to be 0, which means x is never allowed to be exactly 7. Now, if you're keen at factoring, you may have looked at this and said, wait a minute, that numerator factors to x plus 5, x minus 7 over x minus 7. And therefore, these two numbers cancel out, and there actually isn't a hole in the domain. That's not quite true. These numbers cancel out as long as they're not 0. If these are anything other than 0, then we can say they're like 5 over 5 or 10 over 10 or 3 million over 3 million, and they can cancel out. If they are 0 over 0, you cannot cancel them, because the canceling would involve dividing by 0, and that's a no-go. So even if the numerator factors and it looks like these guys want to cancel, doesn't matter as far as the domain's concerned. The original expression does contain x minus 7, and there's really no way to be rid of that. So this restriction in the domain is ironclad. Even if there's a matching factor in the domain, that'll affect how the graph looks, but it will not change the fact that this function has a hiccup where it doesn't exist right at 7. And last one, x minus 2 over x squared minus 5x plus 6. This one's trickier because it's harder to see where the denominator is going to equal 0. We actually have to factor that bit. I'll just leave the numerator alone. In the denominator, forgive me if I gloss over this, I don't have a lot of space left. It factors as x minus 2, x minus 3. And that actually means there are two places where it's not allowed, where this expression is undefined. We get, from the first factor, x minus 2 is not allowed to be 0, which means x isn't allowed to be 2. And from the second factor, we get that x isn't allowed to be 3 either. So because the denominator has two zeros, we end up with two restrictions on our domain.